Hi chaps, John here, Microaces. Before you delve into the build video, I just wanted to give you some quick information about Tyvek and Yoo-Hoo. When Tyvek and Yoo-Hoo come into contact, it can cause Tyvek to bubble slightly or distort, I suppose is probably a better way of putting it. The reason that it does this is because it reacts slightly to the solvent that's used in Yoo-Hoo. It's a what's termed as a petroleum-based solvent. It's not a permanent thing. If you apply Yoo-Hoo to the surface of Tyvek, once it's dried out, once all that petroleum is flashed off, it'll return to its normal shape. So the best way to use Yoo-Hoo with Tyvek is to apply the Yoo-Hoo, let it dry, and then bring the surfaces together. Now, if you're gluing Tyvek to foam, which in the majority of the Percee build, I think you pretty much are, apply the Yoo-Hoo to the foam surface rather than the Tyvek surface, and then bring the parts together once the Yoo-Hoo has dried sufficiently that there's very little or no petroleum solvent that can affect the Tyvek. It was just something that I found out when I was building the Percee kits. I saw a few little bits, little blisters forming little bubbles and ripples in certain areas, and so I dug deeper and found out that it's actually petroleum-based glues and aliphatic-based glues that do this. The only reason it blisters and stays is that the glue gets trapped between two surfaces. As I said, if you just leave the Tyvek open to the air with Yoo-Hoo on, it'll return to its normal shape. So I thought I'd give you that little bit of information. There's more information or similar information in the manual as well, but just take care if you want a really smooth build with no ripples or bubbles or undulations, then heed my advice. We are looking into alternative glues as well. If you've got any suggestions, please get in contact. The one that has been most successful to date is something called Yoo-Hoo Textile. Sorry, it's backwards there. But it's not a contact adhesive. The parts have to be held in place whilst it glues. Not a big problem, but I quite like the qualities of Yoo-Hoo and that it does turn into a contact adhesive. But I thought I'd give you that information. Have fun with the build. I hope it goes really well. Look forward to your feedback on the aircraft, how it goes together, how it flies, and on the new electronics that we've got in there too. So I'll leave you to get on with the build video. Thanks very much for listening. Hi there, John here, Microaces. Welcome to Microaces Workshop and to the first video in the build of the Percee twin-engined aircraft. So glad to have you here. This is quite a new and exciting build for me too. Basically because this particular aircraft is the first in the Microaces lineup to use a product called Tyvek, which we're using for covering fuselage and the nacelles on this twin engine beast. In this video, we're going to be putting together one of the two engine nacelles, and this is a great place to start, I think, basically because this little unit has everything that we need to teach ourselves about how to build using the new Tyvek material. At the moment, we'll build it without the motor or motor mount in, because we won't need that until the aircraft's complete. But we'll go through the whole process of putting this little unit together. We've obviously got some fixed wheel undercarriage on that as well. So that's looking good. Okay, before we start, I thought it might be a quick an opportunity to quickly show you the aircraft in flight. So I'm just going to switch to one of the videos that you may already have seen, just to give you a good idea. There you go. It's enough of that. You're here to build, not to watch flying videos. Okay, let's get down onto the build board. There we go, and we can see our completed item there. But that's not going to show you how to. Let's pop it somewhere we can see it. So there we go. So we can use it as a reference. Okay, where do we start? Well, we've got a number of different sheets of material, as is normal for Microaces, but as you'll see on this sheet, it's not on a framework as our previous builds have been. We've literally produced a sheet and cut out the parts that are needed, leaving little tags in to hold the parts in place. So to actually extract the material, we just nick the tags with our scalpel to extract them. As you can see here, we've already extracted a fair bit to make up our first nacelle. So we've got that. We've also got some plastic parts that once again used for, it's certainly in this part of the build, for reinforcement, and we'll actually start using those in a second. We have the Tyvek material, which is a sheet of it's essentially it's a man-made paper. It's made from man-made fibers. It's about 2/3 of the weight of normal paper, maybe even lighter. And it's obviously, because it's a man-made material, it's tough. It laser cuts, which is fantastic. And it accepts a print as well using our UV printer. So that's great stuff. And we also going to be using, let's leave that there. Let's come to the party. We're also going to be using stickers. We've got a little bit of ply that we need to extract from this particular part. We've got a wheel that's already pre-made, which is fantastic, and a piece of carbon fiber that provides an axle for the wheel to rotate on. So there we go. Good. Right, let's just get some of these pieces out of the way and get what we need for the first part of this build, which is the framework that all of the material that the Tyvek will sit on, get glued to once we've assembled it. So for this, we will need our V13, and you'll see actually, which is quite useful, we've actually laser etched part numbers into this sheet. Most of them are actually sitting on the parts themselves. So if you take the part off, put it to one side, and then think, what part number is that? Then at least you'll have some reference to it. There are a few that are too small to accept the engraving, but in the most part, you've got those reference numbers on the parts themselves. So let's get going to take our V13s out, and as you'll see from the shape of them, they are essentially the sides. Have I got it all? Have I got it all? The sides of the nacelles themselves. There we go. Now, there are, on these particular parts, there are plastic bits that are used to reinforce certain areas. And of course, you could use the technique of taking the plastic parts and sticking them onto the part as it's in situ, which I think is a great idea. But I'll extract these out just for clarity. So up there, and let's also extract, in fact what I'll do, I'll extract those that we need to put plastics onto. So these 17 can come out. There we go. And I will also remove B19. Now this actually doesn't have a plastic part on it. It actually attaches to a plywood part. And are there any more? Don't think so. There are. We'll come to that. But let's bring on our plastics. We need our P9 and P10. I have already cut some of these. So P10, P9, and then we've got our P11s. There we go, tiny little bits. And P12. Okay. That'll do for now. So, first of all, we are going to pop one of those over. Pop our side reinforcements onto this. Obviously, this is the nose area of the aircraft. So they sit like that. In fact, that goes. I've got this wrong. Goes on there, like so. So essentially, you've got them sitting. Try again. You've got them sitting on the outside of the nacelle itself. So let's let's pop those on. Got my it's a new Yoo-hoo, so sometimes it's actually really cold today. So hopefully it won't all come out all at once. Just gently add some glue. Go. And pop that like so. It should be pretty obvious how it or where it sits, because it follows a lot of the same lines as the 2mm foam part. So like so. Repeat on this side. Now you could, if you wanted to, put the glue on the plastic part rather than on here, but entirely up to you. Now this these plastic parts act as reinforcement for the nose parts of the nacelles. Obviously, within the nacelle, we're going to have an electric motor, and although that electric motor is sort of a little over 5 grams, it's still obviously a weight, and you can get an impact if you do land heavily onto one or other of the nacelles. So the idea is this actually reinforces the structure of the nacelle, so it's got some resistance to any forces that might come to bear on it. So those are done. We put those to one side. We've got a few little pieces of leftover from the laser cutting. I don't know, do you call it swarf? I know Simon would call this swarf, I think. He's from a very technical engineering background. So, oh, Simon's the business partner. If you didn't know, you haven't been paying attention to other videos, and he does all of the assembly guides. So anyway, this plastic part here sits there. It blocks off this little piece here. That's fine. It's supposed to do that. Let's just add a little bit of glue. I've changed the camera angle. I've managed to get borrow an overhead tripod. So we're much more overhead with our camera now. It's up there. Oh, you see me pointing at it. There you go. So on that goes. Make sure the holes are lined up. Those slots. See, it's sticking power because it's a new, very fluid Yoo-hoo pour. Okay, so pop that to one side. We'll do those in a sec. I'll just get the plywood. Go, and it's actually a W1 you need. Once again, just cut through the tags, and the part should come free. Should being the operative word. Oh look, didn't cut all the way through that tag. Go. So that just I'll actually put that side. The plywood actually sits on the inside of this foam here, so set it like that. It doesn't really matter which way around it goes. But what we want is when we're facing forward, if we're looking at that, that's the front of the nacelle. We need this little gapped area here to sit on the right hand side. This is for a little bit more ventilation for the motor. The cordless motors do like a decent amount of air conditioning, air cooling, I should say, because they don't have a massive amount of metal in them that acts as a heat sink. There we go. We need that sitting on the right hand side. And then once again, it should be pretty self-explanatory where this all sits. So we can set that to one side. Now these little bits here, what were they? The P11s. They've got some scores in them, and they actually fold. In fact, what they're for, these little things, is the little hole there. But once you fold it over, that sits on top of the hole on the other side. They're actually for the axle to go through, for the wheel, and they actually sit on the bottom of this particular part here. And they are shaped once again so that you can locate them fairly accurately, with the longer side of the part here sitting right at the back of the foam, and then there's a little cutout there that follows the same line as the cutouts in the foam too. So obviously important to get lined up, because if it's not, then you're going to have a wonky wheel. So on takeoff, as you're rolling along, it might go in an odd direction. Anyway, let's just add a little goop. And then we are going to use the properties of the Yoo-hoo paw we'll put that to one side, let the glue go off, and then we can easily make that part stay where it's supposed to. So we bring it back those two parts back together again. Okay, so let's get these folds. So literally just folding it. If you find that it's difficult to fold, then you can just run a knife gently down the scores just to loosen them up a bit. Okay, and on to the next one. Let's just bring so longest side to the rear. This part here. There we go. Squidge it together. Transfer some of the glue over, and then there we go. Right. Whilst that one will have dried enough that it should stay when we bring it back onto. Yeah, obviously got to do it as accurately as possible because we don't get as much chance to slide it around. There we go. There. That's good. And let's give this a go. Looks like it's dried enough. Yeah. Fantastic. Good. I've just noticed a few. Need to change the blade. It's not sharp. Let's use our new sand. Oh, that works well. Crikey. That's aggressive. Use the other side, I think. There's this. That one's looking fine. Good, okay. So we've got all our plastics and our plywood in place. There we go. You can see all those there. Now we can bring those parts together with the other parts that are required. Let's just get the sheet. And let's make some extractions. So let's go V14. V15. V16. V18. V16, as I said before, there we go. And V16A. Now, there's evidence of a change in design after the part numbers had been allocated. There we go. It all makes sense in the end. Do we have anything else we need? Not at the moment. No, I think that will suffice. So now, how do we put this together? Well, first of all, our V17 with the plastic face facing forward, I believe, should slot into the side of the V13 part. As you can see, I've got the reinforcement on the outside. We have our V16. A V16 actually should stick onto V14, and these rear two holes should line up. And that'll give you your indicator of where they go. Now, there should be a little sort of extra bit of material running around the outside on V14 because it's slightly larger at the tail end than the V16 part. But line those holes up there, those two holes, when you glue. So let's glue that down now. So I'm applying glue to V16 rather than V14, as this is the maximum area that'll be glued. If I put glue down on V14, then it's likely I might go over that and put glue into areas where I don't need it. So okay. So with those holes lined up, put that into place. And then because our Yuku is still slightly slippy, I can just move it round until I'm happy with where everything is. So the other part that we need to put on is the part V15, which sits at the top here, slots into one of the covered hole that's at the back of this part here, this bulkhead, and the sides should sit on top of V13 there, and this V13 part should slot into this this gap in that part there. So like so. Obviously, I'm just dry fitting stuff at the moment, apart from obviously gluing that on. So this assembly here should sit with those two cut-ins there, sitting at the bottom of the bulkhead there, and then this front part should run up on the underside of the side portion, the framework, like so, and it should hit exactly flush at the front with the V13 side part. So that all looks like it's going on well. The other part that goes on is the V18, and that actually sits at the back here. That can be fitted after the other parts have been glued in, but that just sits there. So what we're going to do, I'm just going to take everything to bits and then start gluing. So here's our bulkhead. Actually going to apply the glue to the side rather than the bulkhead itself. Pop that in. So the glue acts as a bit of a lubricant as well, so fitting actually usually goes easier. There we go. And now I'm going to pop our little assembly that we did on the bottom there. So let's just add a little glue to the areas that are required. Just going to run a little bit in the gap there, and then some across the bottom of the structure here, and then just up the side of the edge of the part. Okay, let's get that slotted into place. Now, because the glue is quite fluid at the moment, it might not hold as well to that part, but what we can do is we'll just use the technique of transferring the glue over just by bringing the parts together, and then we can just free our part until we've got a little bit more grab on the glue itself. And in the meantime, let's just take a look at where we need to pop the glue here. So we'll run our glue on the areas that come into contact. Front there, on the tab. Pop that into place. Okay, transfer the glue over. Just remove that part for now. Whilst we're letting that dry, we can put this part into place. Go. Like that. Go, that grabs nicely. Make sure it's all in place. As you can see, the V16 actually sits on the underside of this structure rather than on the inside. Somebody's got a very loud motorcycle outside. Probably heard, picked up on the mic there. So now on to our V15 part. So there we go. As you can see, it does all go together pretty quickly. Everything has been engineered so that it should slot together nice and easy. So we've got our nacelle sort of 3/4 built up. What we need to do now, we need to, in fact, we'll leave that part until we've got our side on. So that side then obviously needs to mirror its opposite number, slots into place like so. So we just need to run the glue now onto all the areas that need it. Let's do that. Let's go. Okay, so along the top of the base plate there, into that little gap there, on the back edge, there, there, along the side wall of this here, on the sides here. I'm using the position I have to go to, or the lengths I have to go to. I reference what's gone on the other side. So let's go on the underside. Fill the gap. Just a little splotch there. So we've got everything. Then put that all into place whilst the glue is still wet. And we're actually going to leave it in situ, and if the foam doesn't take with the glue, anything that does pop off would just push into place. So that all looks pretty straight. As you can see, that's popping off a bit, but as soon as that glue reaches its tackiest, the whole thing should come together nicely. Okay, we can put our rear piece on as well. That has a particular orientation, so you just need to check that before popping it on. That sits like so. Just add a little bit of glue so it keeps that in place. Put some on the sides here too. I'm just using tiny little dabs of the glue, not putting great big blobs on. Obviously, we want to keep it as light as possible. So let's just slot that in. Okay, and we'll, after that's dried off a bit, we'll finesse it. Okay, So the next part of the frame, as I said, the plywood actually sits on the inside, and this whole part should slot into place there, and that should all come together nicely. There we go. So let's just glue that in place. Now you can be a little more heavy-handed on this part because obviously this is right at the business end. There's relatively quite a lot of weight up the front there because we've got our motor. So having everything nice and sturdy is always worthwhile in those areas. I think we can sacrifice a bit of lightness for a bit of sturdiness. Good. Right, let's just check our V18. That's all in place. That's great. So we've only got one little half moon to go. Now that sits, there are two little slots in the legs there. That sits there and offers a bit of structure to the skin that wraps around the leg of the aircraft. But before we put that on, we're actually going to pop the wheel in place. Now to do that, we need our little piece of carbon fibre. There should be, I think it's 50 mil that you get in the kit itself, but you actually per axle need, I think it's 18 millimeters, which slots through the wheel itself and obviously protrudes either side and goes into little holes in the side there. So I need to measure out 18 mil of this part and then cut it. And the easiest method I've found for cutting it, because it's quite a substantial, it's 2 millimeters of carbon fibre. It is a tube rather than a rod, but still. Okay, well actually I've got on my wonderful Swan Morton scalpel, I've actually got a small ruler. I'm just putting my thumb in the right place and I'm just going to mark it with the scalpel like so, and then I'm going to take it down onto the board. I'm keeping my scalpel in place, but obviously if it comes out you can run the scalpel along and it should dip down into that mark that you made, and then I'm just going to roll. So I'm just rolling the carbon fibre, and you'll probably see if you're on a billboard that there's a little bit of carbon fibre dust appearing underneath. Just going to keep doing that until I feel I'm getting somewhere. Of course, the danger is that this will fly off stage right and never be found again. So it was worth just taking your time. You can hear when those fibers start to give way into the internals of the tube. So you can then reduce the pressure and take it a little bit easier. See whether we'll get a snap now. Yeah, there we go, snap. So I've got my 18 mil. Let's just check. Well, 17. They do say measure twice, cut once, don't they? Still, 17 will do what we need to do. Now, I'm just sanding cut edges because they tend to splay out a little bit, and the holes that we're popping the axle in are fairly snug. So we've got a little bit of rounded edge there we can use. Obviously, I've got a bit of excess left over, but obviously you've got to take 2 axles out of that. So probably, yeah, 2 axles. So what I need to do now, I'll just pop my axle through the wheel, and then I can mount the wheel. And as you can see, these are nice and flexible at the moment. They haven't got any of the surrounding material, the skin. So pop one, and you should get it to just barely come out of the other end of the material, and then do the same the other side. And obviously you don't want it too snug, otherwise the wheel won't turn. Just make your appropriate. This has come out a little bit too far on this side. I just need to push that back in a bit. Okay, there we go. Yeah, that all seems to be working nicely. So now to secure the axle in place, I'm actually going to use a little bit of CA glue. You can use Yoo-hoo, that would work, but I quite like in areas like this that are superstructural to use a bit of CA. It's going to come out, that is. Oh yes, just a tiny dab. There we go. I need to get some more of that. It's a little bit gloopy. It's supposed to be quite thin, I think. Still, a bit of that gloopy bit. Okay, so that's our wheel in place. Now we can put our little half moon into its area. Try not to glue it to the wheel, or it'll also act as a brake. No. So a little bit of glue on either end, then pop it into place. Change orientation. There we go. And then just pop it into place on the frame. As I said, try not to glue the wheel. There we go. And as you can see, you've got a little bit of a taper to the leg of the wheel as well. But essentially, this wheel will free spin. There's a little bit of resistance there because obviously it moves from side to side. But what I found in test flying the aircraft, it doesn't have an impact on it rolling or landing. So I'm happy with it, so hopefully you will be. Right, so we have our framework here. What we now need to do is to take it to the next level and add the skin. But before that, I'm going to go and make a nice cup of tea. So I'm going to put you on pause. Then when I've got my cup of tea, I'll be back and we shall continue. Well, that was disappointing. The milk's off. What was I to expect? Nobody's been at work for days now. So it's, well, to put that into context, it's kind of over Christmas at the moment. So nobody's been in. Anyway, so let's get on with the build. without my cup of tea. We have the whole framework here. Everything is set. Everything is moving as it. All the bits that should move. That is. So we need to skin it now. Let's get our skin. So, where shall we start? Well, we're going to start. That is you. We're going to start with this lower portion here, which comprises of TN3 and TN4. So let's just extract those from the sheet. And this is obviously very exciting because this is the Tyvek. This is the new stuff. This is what we're all going to learn how to use for future builds, I'm sure. So, and TN3, I'm going to be a bit more careful taking this off the frame because this sits on the outside, whereas our TN3, TN4, I should say, sat on the, or is going to sit on the inside. Nearly there. It's this one. Oh no, and one more. Okay. Put that to one side for now. So we've got two parts here. And I said I was going to be careful. It's not. So, what we're doing here is our one part sits on the inside of our other part, and the TN4 part, which is the part that I've got upturned here, is not as wide as the outer part. So what we need to do when we stick it is make sure that it sits centrally, so we've got a little bit of overhang here and here of the outer part. What we do have to do though is line it up at the bottom of the part there. So just a little sort of by eye alignment. But, so that's what we're going to do. Now, we need to stick this down. We're going to use our Yoo-hoo, which works for Tyvek 2. And what we want is a light smear of this all over. We want this to stick well to the outer skin, because obviously we're going to have to curve this, and what generally happens when you curve two laminated parts is that the inner one buckles slightly. Now if it does, it's not a massive problem, but it'd be nice if it didn't. So getting it all stuck down really well is our aim here. So okay, I've got a little more on this side than I have overhanging that side, but I'm not going to worry too much about that. What I am going to worry about is just getting these two parts well stuck together. we go. Now, whilst that's drying, we're getting a good bond. I'm going to set that aside and we'll just start preparing our other TN1 part. So I'll just extract that off the sprue. I'd be interested to know your thoughts on working with the Tyvek material. Really is a bit of a find. And if you haven't seen before, Tyvek is made by DuPont, which is an enormous company, enormous American company. And it's used for all sorts of different applications. But I don't think anyone's actually used it making aircraft skin or model aircraft skin, I would say. Probably wouldn't work very well as normal aircraft skin. But it was first brought to market by DuPont. I think it was 1955. So it's not like it's a new material, but it's certainly a new material to kit building. And obviously the big advantage of it is that it can be printed onto and it can be laser cut. And also what we need for this is TN2. Now TN2 actually forms junction between these two parts when they come together. Those come together at the back like so, and this little part here just acts as a means of bringing those two parts together nice and neatly and closely, and also obviously provides a continuation of the graphic, and also a little bit of flexibility too. So if you can't get both of these edges to meet completely, you've still got a graphic there which will fill in the gaps essentially. So what we need to do with this is score it on its rear side, just down the center, just using the back of the knife. Okay, I'll just hold it up whilst it's on the board. There we go. And what I can do is just attach it to one of the sides. And I'm just going to leave probably a ½ mil past onto the what am I trying to say? I'm going to allow for around about ½ millimeter of extra material before the fold. That's what I'm trying to say. So once again, a little bit of Yoo-hoo. It's great that the Yoo-hoo works for so well for this material as well. Be very interested to see what we can do in the future with Tyvek too. Is it going to be the wonder material? I wonder. So push that down. Okay, just pop that to one side for now. That's set. Okay. back to the shroud for the lower leg of the nacelle. So that's going to literally sit on there, curve around, come back the other side. As you can see, we've got this curve supported by these two parts of the 2mm. So the best thing we can do is to make our lives easier to installing this. We shape this so that it literally, when going on here, sits very comfortably in place. We literally just have to tack it down. The first thing I'm going to do is just splay out these. In fact, no, I'm not going to do that. Scratch that idea. What I am going to do is start curving this. Now, the best way I've found is getting a paintbrush handle and then just popping that underneath, put my thumb on top, and then just scraping or pulling the part through and putting some pressure down onto the material with the paintbrush curve underneath. As you can see, that's really starts forming. The more you do it, the more it curves. So if you've got a more intense curve, as we have at the front of this part than we have at the rear, then that's where we concentrate our efforts. So if you do it bit by bit, you don't get too much wrinkling on the inner side. You've got your laminated piece. The reason that we've actually laminated it is to add a bit of strength to an area that's probably going to get a bit of abuse, seeing as it's the undercarriage. So having that extra layer of the Tyvek material provides more resilience. So as you can see, that now easily forms that sort of shape, that teardrop shape that we want going around the undercarriage. Now I'm going to bend these out. There we go. In fact, you can, if you want, use some sort of tool. There we go. So now we'll just do a dry fit. So just bring that to the edge, around. This probably needs a little bit of a push to splay all this out. As you can see, some of it splays out the sides there, but we'll tack those down to the side of the framework before we move on. And then you can just check that everything should be where it is. Obviously, there's a panel line down the front of this shroud, and so you can try and make sure that that's as central on the leg as possible. That'll give you a good indicator of how it's supposed to sit. And then obviously we want to bring those two edges together at the back there. We don't have to glue too much of it, just probably the straight areas where it curves here. That needs to sort of dip out to the side to allow enough clearance for the tyre. So let's not hesitate any longer. Let's get the glue onto the areas we need it. So we'll need to little bit at the sweeping back there. Bring that all forward and around that front edge of the curve. Doesn't matter if we get a little bit on the base as well. In fact, I'll encourage it. And then follows all the way around. There we go. Now put a little on the framework of the undercarriage leg. And once again, try not to get any on the wheel itself. And same goes for the other side. And also just a little on this second curve at the front there. I did notice that it's dipping down a bit, so I'm just going to push that up a bit before we fit. And then I'm going to use the technique of getting that as central as possible. First off, I'm using the hole there, which is central, to try and make sure that judgment's correct. So seating this shroud at the bottom of that circle, or so that it lines up with it anyway. Obviously it's a little way off it. And then draw my part back. So I'm also going to add a little bit of glue just to the back edge of the shroud. So when the two parts come together, they'll actually stick. So just get as much of the yoo-hoo off my fingers as possible so it doesn't get transferred onto the surface of this material. I've got a little bit on there at the moment, but we'll clean that off once we've got the whole structure together. So certainly happy with the position of that. The only thing I'm waiting for is the glue to just dry a little, so I can bring that back edge together. Okay, still got good movement in my wheel. I can press those sides down as well, so that the shroud sticks to the framework all the way over. And then just make sure everything is very well seated. Yep, that's brilliant. Okay, so happy with how that's gone on. A little bit of clearing up to do. There's a little bit of excess yoo-hoo on the surface, but we'll get that shortly. There's a little bit here as well. So as we did with the lower shroud, the rest of the nacelle skin we can actually shape as well. Now this now goes on like so, and then these side bits fold up. Now, there are a couple of notches at the front here. They indicate where that fold starts. And that fold then, from there, runs along to the edge of the starter back curve. So you can actually just fold the material so that you get a good edge. This is very much more like card modelling than has ever been done before with a Microaces kit, but I quite like that. You've seen the results of what some people can do with card. It bodes well for future products, that's for sure. So that's as easy as it gets for this part. Obviously, we're dealing with a thinner material, half the thickness of our lower shroud, but it should naturally sit so that the sides come up just a small amount above the side panel here. The reason for that is that we're going to have a motor mount, a ply motor mount that sits into that recessed area, so it should then be completely flush on top. So don't worry if you feel it's sitting a little bit too high. It's supposed to. So, okay, so I'm going to do this one side at a time. I'm going to fix down the central part first. So let's just add a little glue to get it tacked down. And it's obviously important that you get this as central as possible. And flush with the front of the nacelle. Okay. And then it's all about folding the sides up and getting everything into place. So I'm going to do the side that I've glued our little tab onto. I'll do that first. Shift it forward slightly. So let's just get some glue onto the side framework. Now obviously the important areas that this is properly glued to are the edges. So I'll make sure that all the edges have got some glue on before I do any additional gluing. But yeah, just put dots or smears of glue in areas you think you're going to need it. If you like keeping things really lightweight, I've got an eye for that, then obviously less is more. And I'm glad I gave that little extra half mil. That's given us a nice, easy, unstretched return on the rear there. I'm not fighting the material or trying to get it to go places where it doesn't want to without permission. So, well, that's looking good. Let's just tack down this side too. I'm being quite generous. No, maybe not. Okay, let's fold this up now. Oh, the one area I didn't apply glue to was our little tab. So let's get a little bit of glue on that before we move on any further. There we go. Okay. Oh, pick it up. Just do some transfer of glue from one to the other. Come apart for a second or two. And then you can finesse the material down onto the underlying framework. All sorts of ways you can do this. I mean, obviously, finger work works particularly well, but also, I'll show you in a minute, I'll just bring this together. The other thing that you can do is use a nice flat tool, such as the back of your knife. That really smooths things out nicely. There. Yeah, a nice solid flat tool really does help. Obviously, fingers are great, but you get an amount of pressure put in a particular point, whereas this provides a way of evening that pressure out. So it's all looking good, nice and square, straight. Fantastic. Right. Now, I'll just pause because I need to go and get some cotton buds. Here they are. Now this is how we get our glue off the surface of our nacelles. So, cotton bud, lighter fluid onto the cotton bud, soaked in, then gone. 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 Isn't that great? I love that. Love it, love it, love it. That's just, it's a wonder tool. Wonder fluid. There we go. And if you haven't seen any of the other videos where I've used lighter fluid, that's just one of its attributes. Obviously, it dissolves Yoo-hoo pour. And the great thing with that is that if you do get anything wrong during a build, you can take it apart and you can do it again, completely reversing steps of the build, which is, it's pretty special for making model aircraft like this. Yeah. So if you're inexperienced at building, it's an absolute godsend. I say inexperienced at building. I use it all the time. Yeah, and I guess you'd probably say that I was experienced. And there we go. Look, I've just realised I've made a mistake. So we're going to have to use the lighter fluid. We're missing a couple of parts. TN5. We didn't put these on. These are supposed to go on before we put the skin on, or you can put them on the inside of the skin before installation. Oh dear, I always forget these as well. You'd have thought I'd have remembered by now. Now these are actually sort of they sit underneath the skin, just here at the front edge of this part here. So I need to get it, both of these, either side, in and under here. So I am going to grab a little lighter fluid. I'm going to be naughty. I'm just going to, go. Ooh. Just dab a little either side, a bit like a bad aftershave. And that just allows me to peel that back. Just going to slot that into there. In fact, what I'm going to do is add a little Yoo-hoo. So just on either side of there. There we go. And pop that in place. Use the tweezers, Luke. So it's quite important positioning this correctly, because it provides a little saddle for the wing when it touches down, just there. and obviously the position of that is quite important. So there you go. I do need to stick it down onto that side as well. It's just that little glue there. That was the model building gods having their laugh again. If you're inexperienced with building, the lighter fluid's really quite something. Yes, John. Oh, well. At least we can all laugh at ourselves. Oh dear. So, anyway, thank God for lighter fluid. So, let's put you into place. Go. The tweezers. Pop that in. Go. Fantastic. So we'll set that to one side. Just noticed a little more. Lighter fluid on there. That's probably me whilst making my adjustments. Yep, all good. Right, so where have we got to go now? We have still got to do the nose area and this top hatch. So so let's crack on. We'll start with the nose piece first, or the chin, as I like to call it. So for the chin, we will need V20, V21, V22, drag all these out. There we go, and we'll also need drops of plywood on the floor. P15, P being a plastic part. There we go. Do we need anything else? Not at this time. So, these stack up, one on top of the other. They get progressively smaller as they build up. But if you keep the little D lined up, then you should get the correct alignment. So let's do that. So V21 goes on to V20. Yes, V20. V lined up. Thank you. And V22 on top of that. fantastic. And then the final part, the plastic part, you'll notice the D has not been fully extracted. That's because on the long straight, it's actually just been scored. So you can actually fold that in to expose the D, and that return sits down into the whole assembly. And that should provide a good indicator for the alignment of the plastic part as well. So let's just get that into place. There we go. Okay. Right, that all seems nicely aligned. So we need to just set that to one side so it can dry out. And then we need to sand it, or you can indeed carve it into shape. But we do need a very sharp knife for carving that material though. But it works really well. We'll give it a go if I can find a new blade. Right, whilst that's drying, let's get the rest of the material to build up the hatch. So we need V33, 34, 35, and 36. Come on, off you go. There we go. And we also need V32. And plastic parts. Plastic part. Is it plastic parts? There we go. Yes, P16. And also P13. There we go. So let's build up our nose first. So let me just remind myself by looking at one I have done earlier. Okay. Oh, which reminds me, we also need P14. So firstly, we'll build up the part that sits on top of the chin, which is our actually both the same, really, aren't they? Yeah. So our V very thin. Well, it doesn't have its part number on it. V35, V36, and then our little plastic part too. So let's just apply a little glue to our V thin part. This large voided area here is like that to accommodate the big gear and the gearbox, the one that's attached to the prop shaft. So you're just aligning this by eye. Obviously they need to both sit at the same level on the bottom, but then obviously because the V35 has a smaller diameter than the underlying one, and then we just need to make sure that the bits poking out are of equal size. Let's get this other part on. V36. Go. And then our plastic part. Right, shiny side. That's the shiny side. Put the glue on the shiny side. I don't think it really matters, but when you put the glue on the shiny side, it doesn't find if it goes on the other side, it makes it look a bit weird. Like me, looks a bit weird. Chorus. Just put that, seat that on the board. Just muck around with it till I'm happy. Let's take a closer look. Make sure that plastic part is sitting. Come down a tiny bit. Tools out. Okay. I know I do keep going on about it, but this is why I really appreciate something like UV glue, is that because it's still wet, we can move it around until we're happy, and then set it aside, and within 30 minutes or so it's good and solid. Okay, the other part we need to do is create the hatch top. Now that's actually reinforced with our plastic material. The reason for doing that is obviously we're using Tyvek for the top, which doesn't have as much structural integrity as the 1mm foam that we normally use in our other kits. But also, obviously, that hatch may come off a fair few times just to either lubricate or change or check the motors. So if it's reinforced, hopefully it'll do the job for longer. What we can do, obviously, this curves round, sits on top of there. We can actually curve this material, pre-curve it. There's no need to score it. You can literally just bend it, essentially. into shape. And it will plastically bend and stay in position for you. Okay. The other thing we're going to do is get our foam parts and just tack them onto the inside of the areas that this is going to sit in. So our V32, that's just going to pop onto that part there. Now we've got to line the slots up. The slot on the plastic part is not as wide as the slot on the foam part, but that reason for that will become apparent fairly shortly. Right, now V33 onto this area here. Go. Tag off at the top. Go. And you'll notice obviously B33 is scored in the shape of this area here. And what we're going to do is actually remove that that particular part of V33 from this whole arrangement, but we'll wait until we've got everything glued together. This is obviously providing some structural integrity until everything's assembled. And that's the idea of scoring it rather than just cutting it out, because obviously it would be a very weak part with a very small bridge at the top. So we leave it until the very last minute to extract it once this whole hatch is put together and done. So obviously we've got these little tabs that we can fold down onto the material now, and then we can fold this material up and glue together. So these tabs are actually going to go down onto the side of the foam rather than wrapping around the outside. So just add a tiny bit of glue to each of them, and then they're scored, so they should fold fairly readily onto the side of the foam. Okay, one side done. Okay. Go. Just need to glue those up now, so we'll add a little more glue. Go. catch the sides, and we'll do it on the other side as well. Actually bring that to bear, transfer some of the glue over, and then we'll let that dry off. Same goes for this side. There we go. And then our little T-tab, just fold that over on itself. Glue it together. Go. So that folds over like so, and that, before we glue that up, that can actually slot into V32, go through the plastics side, and then that, the top of the T should nestle into the foam, and that's why the foam slot is wider than the plastic slot. There we go. And we've got a little tongue sticking out there that inserts into that slot just there. And everything gets held together, so it doesn't fly off during takeoff, during the flight, might come off during landing, depending on how heavy your landing is. So when we bring these sides down, we're obviously trying to make sure that they align well with the part itself. Go. We're lacking a bit of glue on this side. I must have missed that. Add a little extra. Go. Transfer the glue over now. Just have to let that set for a little longer and then bring those together again. Right. Here we go. Time for a new blade. That, on with a new one. So I'm going to show you a new technique for shaping this 2mm foam. And we can actually carve it. What we want to do, obviously at the moment, we've got this sort of staggered slope of material, and we want to make it nice and smooth. There's a sticker going over this, the chin part, so it'd be nice to get it as smooth as possible for that sticker. And essentially, I just use a gentle sawing motion to cut through, and the plastic at the top, the plastic part that sits at the top of the stack, acts as a nice guide for the blade. Now I haven't done it perfectly all in one go, although I'm sure that's absolutely possible. I'm just doing it quite gradually, so I can keep good control and I don't go too far with it. Let's try going, it went the other way. Not as well. Oh well. Yes, the sawing action seems to work best where you run the blade across the material. So there we go. Let's do the other side. It's amazing what a fresh blade can do. There we go. I'm just going to finish it off with the smoother side of the sanding stick. Oh look, that's the side I must have used for the carbon fibre because it's now gone grey. As I said, it's going to be covered up with a sticker anyway, so not a problem. And I find that to be a lot quicker to do than just sanding alone. So anything that's slightly quicker, I'm all for. Let's just get rid of that. There's bits of swarf. Okay, right, so this part here fixes to the front of the nacelle there, but actually probably what we're going to do first is get that sticker on. Now, that sticker is, stop the light shining, is this one here. Now, if you look closely at this sticker, especially if you look at the cut lines, you'll see that it's quite sophisticated, I think the term is. And there's quite a few areas where it could possibly tear when coming out of the sticker material. So we're going to be very, very careful at lifting this out. We're going to start with a corner right at the top of the material. And just using the knife to tease it out. And then once I've teased, I get my tweezers and start the process. I'm going to move those tweezers around so that the material, I'm trying to avoid any ripping of the material as it comes out. So I've just freed that off to some extent. It's going to go back down onto the backing paper, but hopefully not with as much sticking force as it has before, so it'll come off more easily. And I'm going to free the next portion of the top of this sticker. Once again, using the tweezers, start peeling off all the way down, giving it a bit of a wiggle. Okay, come off there. So using the tweezers just to apply a little more pressure to where I need it, and hey presto, it's off. Now we need the special sticker fluid that we use to stop the sticker sticking too completely. initially, so we can move it around. And that special liquid comes from the tongue, also known in other circles as tongue water. So I'm aligning that U, the bottom of the U, with the indent at the top of our stack. Now, I've done something wrong again. Something I have not done to this part that I needed to do before I attach this sticker. So I'm going to put this sticker back down, although fairly gently, so I can pick it back up again. And I'm going to pop a little bit of glue into the indents at the top. And those of you who have built Microaces kits before will know that this is where we're going to put our magnets to keep the hatch on. And I need to put those in before I put the sticker on. So I'm going to go and get some magnets. I'll put you on pause. Magnets. Magnets Magnuson. So, one in each divot. And I'm going to put each one towards the back of that divot. When I say back, I mean that way. At the moment, it doesn't matter about the orientation of the magnet, because these are our initial magnets. Now I've just stuck my magnets to my knife. That's where I always put them when I remember them. So those are now in place. There's some glue in there too. That'll dry off, but in the meantime, let's get our sticker back. Add our tongue water. And pop the sticker back on again. Right, time to concentrate. So first thing we're going to do is fold our top parts back over the top of the stack. And there's a little tab that folds down behind just to add a little bit more security. And we've got, if your eyesight's any good, you'll notice we've got a little area that's been cut out here as well. That folds down into our little air intake. So that's all folded down nicely. Then we're going to fold our sides down. Now they're a little longer than required. So we're just going to roll those round the edge there. Same again on the other side. And then we can fold these in on themselves at the bottom, like so. They are forming a couple of little ears there, but there are a number of things we can do with those in a second. And then fold our last underside part down on itself, like so. So with these little ears that have appeared because of our folded in sticker, a couple of things we can do. Either we can just fold them up into the arrangement and they'll fold in once they're glued onto the front, or we can actually just snip them off, which I'm going to do using my very sharp scalpel. So there we have our little chin arrangement all wrapped up. We can now add that to the front of our nacelle. So we can be generous with the glue here, that's for sure. Fantastic. Good. Okay, I'm just going to pull that apart. Yeah, one of the properties of Yoo-hoo, as a lot of you will know, is that it can produce a lot of string. That's one of the downsides, but you get used to it because I think all of the other properties it has are worthy to put up with a bit of stringing, a bit of web. Right. Whilst that's drying, let's just remove. Oh, yeah. Let's push down the bits that haven't set yet, or have now set. There. Fabulous. And what's going to happen is that's going to go on the front of there, but not quite yet. Firstly, we need to remove the bit of V33 that is scored. So that just means running our knife, and this, once again, this is where a sharp blade really comes in handy. Just run it around. There we go. And that bit's gone. Now we can attach the nose piece as well. The upper nose piece. Yoo-hoo. You're reaching for my CA. Don't need it. Go. Glue transferred. Once again, we'll pull that apart. We'll pop that on in a minute. The advantage of string. It's magic. Okay, where were we? Put the chin on. Give ourselves all the opportunity we can to get it properly aligned. Love it. Good. Excellent. a little bit of glue on there. That's fine. Good. With the other one. Yep. Which reminds me, we can put our little trim wrap on there too, which is the continuation of this little pinstripe along the body of the nacelle. So on your sticker sheet, there should be a suitable strip. That just needs to be applied as required. Now it is longer than required, so you can just nip it off at the desired location, like so. And where it actually covers over that little channel at the top, you can actually, if you want, just remove it. There we go. Fab. Okay. Let's pop this on. Marvelous. Right. So once that's on, we have to do a similar amount of carving on the stepped area at the front as we did on our chin. But obviously this is a little bit more difficult, I think. I think you might agree, a little bit more difficult because of the curve. But still, we can use the same technique. It just might need to be a few more stages. Well, it seems to be going quite well. How about that? Oh, I don't think it, oh, I might need to get the sanding stick on that just a little bit, but that went better than expected. My building skills certainly, I will say this when my building skills do go down when I'm being filmed. I'm usually much better than this. Yeah, right. We all believe that, don't we? So anyway, I may have surprised myself, but there we go. And look, all one piece, carved off. Marvelous. Right, now we've got another sticker to go on here, but I won't fall into the same trap again. We need to put some magnets on here. So let's just add our dollops of Yoo-hoo. And we'll let that dry off a little. So it's quite tacky. And you'll see the reason for that in a minute. And whilst that's becoming tacky. Let's get the last part of this particular build off the sprue. That is our TN7. There we go. And our trusty brush handle, and then I am shocked and delighted at how easy it is to shape this new Tyvek material. It's brilliant. Here we go. Now, magnets. The magnets we put in here have to be oriented in the right way to be attracted to the magnets in here. So I'm going to get my magnet 1 and 2 and just pop them where they should be there. Now I want to transfer those in that orientation to the holes in the top there. Now the only way that I've worked out I can do that well is by just sliding the knife underneath the magnet I've just put on there and popping that off, and then it needs to go there, and then I just turn the knife over and pop the magnet here, slide that off, and away we go. Now using plastic tweezers, because obviously metal tweezers would just ruin it, just make sure the magnet's where it should be. So let's try that again. It doesn't always work, and the knife doesn't always come away so cleanly, as in it gets a lot of glue on it. But we know how to clean that off now, don't we? Okay, I've got the magnet. Turn it over, pop it in the hole, slide the knife out. We're there. Absolutely fantastic. So now we've got the magnets in place, we can now always move the magnet to the wrong place, get his tweezers, and now it's sticking to the tweezers. But it all went so perfectly well, didn't it? Until the fool got involved. Right, there we go. I'm moving these to the back of the voided area, the hole, as I did with the others, so they sit above each other. We want good alignment. Now we need to sticker up our front. So that's this particular sticker here. I haven't got the sticker numbers on at the moment, but okay, we send you out a kit. So once again, this is a sophisticated sticker, and what I'm actually going to do is start on the big semicircle. Okay. Just work on peeling that off. Oh, a good tip here is make sure you don't have any glue on your tweezers. So if you have any residual glue on your tweezers, that's going to stick quite nastily. So okay, well, we didn't do too bad there, but we have brought some of the material that we're not supposed to have with us. See if we can extract that central part there. Well, it actually looks like it hasn't been fully cut through, which is a bit of a problem. Okay, well, let's put it back down on the sheet, and then we will. This doesn't normally happen. Stickers normally come off relatively cleanly, but I can see that there are a couple of areas where the cutter blade hasn't cut all the way through. So I'm just going to take my blade and push that through. So you see the top of my head there. You're gonna have to put up with that if you can count the fleas. There we go. Released tweezers. So once again, I think a bit of tongue water just on the plastic bit. Okay. Shifting it around a bit. Okay, so once we've got it to this situation, the first thing we do when we've got that U shape down onto the underlying plastic that's at the top of the stack, we then fold the sticker down and over the magnets, and then there's a little tab that then goes up to the side of the nose there. So just press that down as well as you can, and then the sticker should fall down to the side like so. Same again on this side, like so. Oh, not too bad. Not too bad at all. That seems to return there a little bit, but maybe we had it slightly twisted. But that'll do us. Excellent stuff. So the last thing to do, I think, well, let's just check. A little tab goes in there, and the magnets sit down there. Good. They're not fully set here at the moment. They were pulling off slightly, so we won't do that again until the Yoo-hoo has fully bonded them. But what we will do is we will pop, get it the right way around, which is that way around. We will pop our cover on, and that will finish things off and finish our nacelle. Well, the other one we did earlier. You will have to do a second one. It's all good practice. All good practice. So this literally just glues straight onto the little plastic framework that we created, and just a little bit of glue and the edges. It doesn't lift off, and then once that's applied, as much or as little on the framework as you like. And obviously we just look at the sides and where the material comes down on each side to make sure that it's lined up correctly. It should be a pretty good fit. There are some adjustments that I need to make on the stickers so that they're a good fit too, graphically. So there we go. We have one nacelle perfectly formed, almost, to go with our other nacelle that's perfectly formed. Well, there we go. Nacelle's done. It only took us 2 hours and 20 minutes. Isn't that fantastic? Good. Anyway, thanks for watching. I hope this is really useful. We're on to the fuselage next. The experience that we've had here with the Tyvek is going to really help us with that process. But until the next time, thank you very much for watching, and I shall see you in the next video. Cheerio.